Hey, what's going on, guys? I'm Zero Davila. Welcome back to Save Our System IT. Today we're going to start off a well-promised series about Bash and Bash scripting. The first half of the series will be mostly the commands, theory and structure such as operators, variables, if statements and loops. We have three types of those: for loops, while loops and until loops. And then we will move on to actual useful scripts for day-to-day use to automate work. Bash is a Unix shell and command language written by Brian Fox for the GNU program, for the GNU project as a free software replacement for the Bourne shell. It was first released in 1989 and it has been distributed widely as a default shell for Linux distributions and Apple's Mac OS, or formerly OS X. In 2016 it was also made available by Microsoft for use in Windows 10 as an anniversary update, albeit it's not installed by default. Bash is a command processor that typically runs in a text window where the user types commands that cause actions. Bash can also read the commands from a file called a script. Like all Unix shells, it supports file name globbing or wildcard matching, piping, here documents, command substitutions, variables and control structures for conditioning, testing and iteration. The keywords, syntax and other basic features of the language are all copied from SH. Other features are copied from CSH and KSH, and the shell's name is an acronym for Born Again Shell, punning on the name of the Bourne shell that it replaces. To maintain an old tradition for novice programmers, we're going to start off with the famous Hello World script, and that is, when executed, it will print out to the terminal the words Hello World. In Bash, the script has only two lines. The first indicates the location of the interpreter, the program that runs the script. It's called a shebang, and it's the place on my machine where Bash is located. And the second line is the only action performed by the script, which prints Hello World on the terminal using the echo command. If you get a command not found error when trying to execute the script, that means the shebang is either wrong or you have Bash in a different folder. And you can find it to correct the shebang using the locate command, with the syntax being locate bash. We can execute the script by writing the name of the interpreter before the name of the script. That works too. And when doing this, we don't even need a shebang. But generally, we want to make the script executable, and we can do so by using the chmod command with the option +x and then followed by the file name. We will talk about permissions in detail later, but as novices, all you need to know is that at this point you can run an executable script by prefixing the file name with the directory. If it's the current directory, we will prefix the file with a simple dot. The dot is always the current directory, so dot/script name and hit enter. Now let's write a simple backup script, just so we demonstrate how we can execute commands from within a script. It's not really meant to be used, we will write a better one later on. So instead of printing a message on the terminal, we create a tarball of a user's home directory to have a backup. A tarball is an archive made with a tar program, similar to the zip format archives. In this example, /var is the folder in which we will place the tarball, and /backup.tjz will be the name of our archive, and /home/0davila is the current username I am logged on with. And that's my home directory. So everything I have on this computer as this user, it's in this directory. And also we'll have three options after the tar command. C is for create, to create a new archive. Capital Z is to compress or uncompress. And F is for file, so we place it as the last option, so we can specify the path to the file to be created afterwards. If we just execute the script, we get an error, and it will tell us that the operation is not permitted. This is because the /var directory is in the root directory, and that means we require elevated privileges to be able to write to the root directory. So we just prefix the command with sudo and then write the password for the current user and press enter. Sudo means superuserdo, and it offers us elevated privileges for 30 minutes. And in the password input field, the password will not echo, so it will not be visible in the terminal. Now let's talk a little bit about file descriptors and redirecting. Basically, there are three file descriptors. Standard in, where we input text into the terminal, standard out, where the terminal shows us the output of our commands, and standard error, where all the errors go. Basically, you can redirect standard out to a file, redirect std error to a file, redirect std out to std error, redirect std error to std out, redirect std error and std out to a file, std error and std out to std out, and redirect std error and std out to std error. As a little side note, using the less command, we can view both standard out, which will remain in the buffer, and standard error, which will be printed on the screen, but will be erased as you try to browse the scrollback buffer. Redirecting the standard out to a file is done with the arrow to the right for overwriting the file, or double arrow to the right depending at the end of the file is its content. One example would be the output of the ls command sent into the ls.txt file. Here a file called ls.txt will be created, and it will contain what you would see on the screen if you type the ls command and execute it. Now, redirecting the standard error to a file is done with a 2-character symbol, the number 2 followed by the arrow to the right. Here a file called greperrors.txt will be created, and it will contain what you would see on the standard error portion of the output to the grepda asterisk command. Standard out to standard error can be redirected with a 4-character symbol, the number 1 followed by the arrow to the right, the and symbol, and the number 2. And standard error to standard out will be redirected with the same 4-character symbol, only that it's prefixed by the number 2 and suffixed by the number 1. If we pipe it through the ls command, we will see the lines that normally disappear, only that now they are being kept. And finally, sending the standard error to and standard out to a file is done with a 2-character symbol, the and symbol, and the arrow. And it will send all the output of a command to a file. This is suitable sometimes for cron entries, if you want a command to pass in absolute silence. The rm with the -f option followed by the value of the find command /name core will delete any file called core in any directory. Notice that you should be pretty sure about what a command does before wiping its output. Now it's time for the section on piping commands. A very simple and practical way to use pipes and why you may want it. Pipes let you use in a very simple way the output of a program as the input of another. Our example is an alternative to the ls ***txt command to list all files with the .txt extension. Here the following happens. First, the command ls is executed, and its output, instead of being printed, is sent or piped to the grep command, which is a sort of filter, and in turn will only print the lines which match the regular expression pattern /.txt. Now we have variables. Variables are places in memory where values are stored, like boxes with names that contain various things. So now let's rewrite our hello world program using variables. So line 2 creates a variable called str and assigns the string hello world to it. Then the value of this variable is retrieved by placing a $sign as a prefix to its name. Please try it and notice that if you don't use the $sign, the output of the program will be different, and most of the time not what you would want it to be. So now we execute the script, and we can see hello world being printed. Now let's close up this video with a better backup script using variables. So let's write backup to.sh. Let's have a shebang on the first line, then have a variable that will be the location of the archive. So /var/mybackup.tjz. And this script introduces another thing. Notice the expression $parentheses date plus %sign year month day. If you run this script, you'll notice that it runs the command inside the parentheses, capturing its output. In the script, the output file name will be different every day, due to the format switch to the date command. You can change this by specifying a different format. So now execute the tar command. You'll create a compressed file and offer it a variable and the targeted directory. A more clear example would be outside of the script using the echo command. When we follow the echo command with the letters ls, it just interprets it as a string and prints out ls. But when ls is after a $sign and inside parentheses, we see the output of the ls command printed out. And that's about it for today. Don't forget to like, share, and subscribe. Any questions you might have are to be left down in the comment section or on our website www.sosit.co. Again, that's www.sosit.co. Thanks for watching and have a nice day.